Question 14. So part 1, explain what lowercase x and lowercase y stand for in this inequality, and explain what the inequality models. So lowercase x is the number of bottles of x produced, and lowercase y is the number of bottles of y produced. And from this, write down the so from this information, an analyst wrote this down. So this is basically our first constraint, looking at it from the point of view of A and B needed for each bottle of liquid. So from ingredient A, we can see that 4 lots of little x plus 3 lots of little y is got to be less than or equal to 84. So for part B, use information to write down another inequality. So looking at the ingredient B, 2 lots of little x plus 5 lots of little y has got to be less than or equal to 90. That's our constraint for B. Now for part C, we're being asked to represent these two lines on the graph paper. So going back to my first constraint with regard to ingredient A, if x is 21, y would be 0. Equally, if x is 0, y would be 28 to equal 84 on both occasions. Hence my coordinates 21, 0 and 0, 28. So that's constraint for ingredient A. Now with regard to ingredient B, in theory I could say 45, 0 and 0, 18 would give me 90. But 45, 0 wouldn't fit on my graph paper, so as an alternative, let's say when x is 30, y must be equal to 6. So I'm going to plot the 2 points 36 and 0, 18. 36 and 0, 18, so that is my constraint for ingredient B. Shade the region that is not required, so I'm shading the region greater than these lines, so up here, leaving us this bit here. So for part 4, the company needs to produce the same number of bottles of x and y each day. So find the maximum numbers of x and y that the company can produce. So we need x equaling y, so I've drawn in the line x equaling y here to help me, going through 2, 2, 4, 4, 6, 6, 8, 8 and so on. And I can see there that the biggest number that I get, which is inside my required area, is 12, 12. 13, 13 takes me into the shaded bit. So 12 of each is my answer for part 4. Now on 5, I'm told on one day the company does not have to produce the same number of bottles of x and y. Write down the maximum number of bottles that can be produced. So I can see, looking at all my various options here, that inside or on my constraint, obviously this is less than or equal to these each time, I've got 3 possible coordinates. I've got 10, 14, 11, 13 and my original 12, 12. Either way, my maximum number of bottles is still 24, albeit I can now do it in 3 possible combinations.